For this experiment, you will need ethyl acetate and hexane as solvents, a mortar and pestle, pure acetaminophen, acetyl salicylic acid, and ibuprofen, some glass capillaries, a TLC plate, a beaker and a watch glass, an ultraviolet lamp, and this is the silica gel that we are using today for the TLC plate. Take a spatula head's worth of sample, put it into the sample vial. This one is acetaminophen, and then add about 1 milliliter of ethyl acetate. Cap that sample holder, shake, and wait. Keep track of your samples. Identify each of the sample vials. Take a pill of the unknown painkiller, put it in a pestle and grind it. Grind this to a fine powder, and then we will dissolve this in ethyl acetate. The inorganic binding agent in the pill will not dissolve, but the active ingredients will. Transfer the grinded unknown painkiller into a sample vial and then dissolve with about 1 milliliter of ethyl acetate. Stopper that sample vial. Again, there will be inorganic solids inside this sample that will not dissolve. This is what a TLC plate looks like up close. You can see that it's actually a piece of plastic, and there is a monolayer of silica applied to its surface. The little gaps between the silica particles is enough for capillary action to drive the solvent from one side of this paper to the other. Things to not do to the TLC plate include flexing it. When you flex it, it will drive off silica from the surface and crack it. You can see that this one is damaged here in the corner. Also, this one's already damaged, so I'm not going to worry too much about this one. If you touch the TLC plate straight on with your fingers, you'll do two things. You'll disrupt the silica powder adsorbed to the plastic, and you will also leave a grease spot on the surface of this TLC plate. That grease spot is hydrophobic. If the solvent that you're using in your experiment is polar, then the solvent will divert around your greasy fingerprint. With a pencil, place 4 equidistant spots close to the bottom of the TLC plate. This is where you are going to spot the samples. Using a glass capillary, put 1 spot of your known substance on top of that X. Let that dry, and then do it again. It is important that the spots be small and tight, not big and round and diffuse. It is also important that the spots be not close to the bottom, in which case they would be under the liquid level, or too close to the edge where the flow up the plate will be turbulent. It is also vitally important that you keep track of which spot belongs to which chemical. Into a beaker, place a 1-to-1 mixture of ethyl acetate and hexane, and then place your chromatography plate into this tank. the solvent will start moving up that TLC plate immediately because of capillary action. Put a watch glass on top of the beaker to hold the vapors in. We're going to allow the solvent to move up to about 90% of the height of the TLC plate before stopping and taking it out. The front is about 90% of the way up the paper. Take it out. Place it on a flat surface, and then while the TLC plate is still wet, mark the position of the solvent front with a pencil, because when this dries, that level will be lost. An ultraviolet lamp. We're going to place our TLC plate into the lamp, and this TLC plate is coated with fluorescing silica, and so we can see how far each of the dots has moved. And in this case, with the fourth dot being the unknown, it is quite clear which dot is which. Okay, under the lamp, go ahead and with a pencil just mark the outline of each of those dots, so that when we bring the plate back out into visible light, those positions are still visible to us. Using a ruler, measure from the X's to the solvent front. In this case, it looks like it is in the 44 millimeter region. And then measure from the X's to the top of the dot. Record these numbers and then divide the distance that the spot has traveled by the distance that the solvent has traveled. This gives you something called the retention factor, RF. Record these numbers in your lab report.